Okay. 0 to 10 kilometer. 0 to 10. 1 0 to 1 0. हाँ 0 to 1 0. उसको याद है ना एडवांस वो नहीं एडवांस तो क्रोम है ना ये हाँ उससे कर ले फायरफॉक्स से इस पे लॉगिन करना पड़ेगा क्या इसमें नहीं मैं वो हटा रहा हूँ उससे Yes. कोई नहीं Hey, hi guys. So we're going to start with Git and GitHub today. So we'll be discussing how to use Git as a version control system. We would be discussing how to use GitHub. I will give you a live demo on how you can set up your own Git repository and how you can make a pull request, fork a repository and make a pull request on GitHub. We will end up with some discussion on how to get involved with open source software. And for those of you who are enrolled in this course, so I would also be telling you, how you will be able to submit your assignments by just simply pushing your HTML files directly to your GitHub repository, and GitHub automatically hosts those pages, and I will be able to see all that stuff. Right. So let's begin. And so what we're going to learn today is about Git. So what Git actually is that Git is a version control system. Okay. Why do we even need to use version control in the first place is something that we would like to address, is that why version control in the first place. So the answer to that lies in a lot of things. First of all, let us just assume कि आप लोग जैसे projects वगैरह करते हो, right? तो मान लेते ग्रुप प्रोजेक्ट्स करते हो और आपको रिपोर्ट लिखना है और सारे दोस्तों को मिलके एक साथ लिखना है. तो जो फंक्शनैलिटी दीज डेज सर्विसेज लाइक गूगल ड्राइव या फिर ड्रॉप बॉक्स वगैरह प्रोवाइड करते हैं, right? You 2-3 people can together log into Google Drive, and then you can edit some of you editing some parts of the source code, the document, maybe page 1, somebody else editing page 2, somebody else editing page 3, और वो सारा काम एक साथ हो रहा है, and everything stays in sync with each other. एंड सबसे बड़ी बात है कि आप ये कर सकते हो गूगल ड्राइव पे या फिर ड्रॉप बॉक्स पे. अगर आपने नोटिस किया होगा, ऑन द फाइल इन द राइट साइड पेन यू विल सी समथिंग कॉल्ड द हिस्ट्री ऑफ द फाइल. यू कैन एक्चुअली चेक बेसिकली लास्ट टाइम क्या क्या एडिट्स हुए थे, किसने कौन से एडिट्स किए थे, और आप उनमें से किसी के एडिट को हटाना चाहते हो. आपके किसी फ्रेंड ने कोई ऐसा पैराग्राफ लिख दिया था, दोनों आपने दोबारा लिख दिया वही काम, या फिर किसी ने अच्छे से नहीं लिखा, उसको कुछ थोड़ा बहुत रिवर्ट करना है, तो ये सब चीज़ें हम कर सकते हैं. So that is the basically the functionality that we desire in when working with source code as well. So if you consider very big projects like say जो Android operating system है, या फिर Chrome browser है, या विंडोज ऑपरेटिंग सिस्टम है, मैक ओएस है, तो मैं बड़े एग्जांपल इसलिए दे रहा हूँ बिकॉज द इफेक्ट इज इजी टू अंडरस्टैंड. छोटी से छोटी चीज़ें, इवन स्मॉल मीडिया प्लेयर और म्यूजिक प्लेयर और ब्राउजर और इवन an app to say browse photos, they also involve a lot of code, lot of files, and usually not one person is working on it, more than one person is working on it, right? So uh, the functionality that we need is that we need backup and restore, so that we can go back in time and see how the file was earlier. क्योंकि आप देखते हो कि कोई सॉफ्टवेयर आप यूज़ करते हो, उसके अलग अलग वर्जन्स आप यूज़ करते हो, तो अगर आप रिपोर्ट करते हो कि कोई बग हुआ है कि मैं VLC यूज़ कर रहा था, VLC 1.9 में MKV वीडियो चला रहा था और क्रैश हो जाता है, तो उसमें फिर क्या है कि हो सकता है कि जो VLC डेवलप कर रहे हैं वो लोग मूव ऑन कर गए हैं, और वो लोग अभी करंटली ऐसा हो सकता है कि वो लोग काम कर रहे हैं 1.9 पे नहीं कर रहे हैं, 2.0 पे काम कर रहे हैं, तो उनको 1.9 का सोर्स कोड देखना पड़ेगा टू बी एबल टू understand that what went wrong in the 1.9 edition, right? So they need to go back in time and look at that code. जो फंक्शनलिटी माइक्रोसॉफ्ट वर्ड में फॉर एग्जांपल होता है अंडू करने का, बट आप अंडू जनरली एक सेशन के अंदर कर सकते हो, फाइल बंद कर दो, दोबारा खोलो तो आप पिछले वाले सेशन के एडिट्स आप दोबारा नहीं देख सकते हो। वर्जन कंट्रोल सिस्टम्स यही बैकअप एंड रिस्टोर फंक्शनलिटी प्रोवाइड करते हैं ओवर अ लॉन्गर पीरियड ऑफ टाइम, ओवर डेज, मंथ्स, ईयर्स, राइट? Then the second part of the problem is the synchronization problem, that multiple people can work on this remotely, और हर चीज़ रिमोट होता है। अगर आप एक ही डेस्क पे बैठे हो तब भी आप दोनों के लैपटॉप अलग अलग है, तो वो भी रिमोट होता है, और अगर कोई डेवलपर अमेरिका में बैठा है, कोई डेवलपर इंडिया में बैठा है, तो वो भी रिमोट है। इट्स ऑलवेज रिमोट, राइट? यू आर नॉट एक्चुअली वर्किंग ऑन द सेम कंप्यूटर इटसेल्फ. To keep people synchronized, so that say you have a project and you are working on some files and your friend is working on some files, those files are not related to each other, तो उस केस में तो यही अच्छा होगा कि आप अपने चेंजेस कर पाओ, वो अपने चेंजेस कर पाए बिना एक दूसरे के लिए वेट करे हुए, और दोनों के चेंजेस एक साथ मर्ज हो जाए किसी तरह से। So version control systems provide you systems like synchronization. All version control systems provide you. इन दोनों मेन फीचर्स के वजह से हमारे पास एडेड बेनिफिट्स क्या आ जाते हैं कि हम अंडू कर पाते हैं, बिकॉज वी हैव द एंटायर हिस्ट्री। हम बैकअप एंड रिस्टोर वाली फंक्शनलिटी की वजह से वी कैन अंडू, एंड अगर कोई मिस्टेक, कोई बग कुछ इंट्रोड्यूस हो गया हमारे सोर्स कोड के अंदर, हम अंडू करके अच्छे वाले वर्जन पे चले जा सकते हैं, राइट? हिस्ट्री ट्रैक करना बहुत इंपॉर्टेंट चीज़ है। मतलब व्हाई आई पुट दिस सेपरेट स्लाइड अप हियर इज दैट sometimes what happens is and it's my personal experience, कोई बड़े सी project I have worked with Android, the Android open source project, which is basically the Android operating system, जिसको compile करके आपके फ़ोन पे जो Android OS चल रहा होता है। तो sometimes I've been looking through some of the codes and sometimes it looks like यार इन्होंने ये इस तरह से क्यों किया है, इसको तो दूसरे तरीके से कर सकते थे। So if you also like along with the source code in its current state, अगर आपको हिस्ट्री भी दिखता है तो आप हिस्ट्री पे गो बैक करके देख सकते हो कि शायद पहले डेवलपर्स ने 5 और तरीके ट्राई कर लिए थे और उनमें से ये वाला तरीका बेस्ट आया था। बड़े प्रोजेक्ट्स की जब हम बात करते हैं तो राइट नाउ सोर्स कैसा है, उसके साथ साथ वो इस स्टेट पे आया किस तरह से, वो समझना बहुत इंपॉर्टेंट होता है। So when you work on bigger projects, you will automatically start realizing this yourself, that looking at not just how the code has been written right now, but also how it was written previously is very important to understand how this project works. और उसके बाद because of the feature that we can undo changes, we also end up with a nice feature called sandboxing. अब sandboxing क्या होता है कि शायद आप लोगों ने गेम्स खेले होंगे GTA San Andreas टाइप के, एंड इफ यू लुक अप ऑन विकिपीडिया यू विल सी दैट दीज काइंड ऑफ गेम्स आर कॉल्ड सैंडबॉक्स वीडियो गेम्स। सैंडबॉक्स क्यों होता है? बिकॉज दे रेप्लिकेट योर रियल वर्ल्ड इनटू अ स्मॉल टाइनी वर्चुअल वर्ल्ड वेयर you can do some experiments without breaking things. So you can like shoot people and crash cars and do a lot more things. So सिमिलर वे अगर आपका प्रोजेक्ट मेंटेन हो रहा है और एक पर्टिकुलर वर्जन मेंटेन हो रही है, तो उसमें क्या है कि से यू वांट टू ऐड सम एक्सपेरिमेंटल फीचर्स, ओके, एंड also along with that the other developers in your team, they are also working on fixing some bugs in the current version adding some new features, right? So what you would want is कि आप source code का एक copy बना लो और उसके अंदर अपने experimental changes कर लो, और अगर वो experiment चल गया तो अच्छी बात है, तो you can just whatever changes that you made, you can merge that along with the original source code. And if it did not work, तो कोई बात नहीं, आपकी environment एक sandbox थी, real environment को आपने छेड़ा ही नहीं, तो whatever changes you did, you just simply delete, go back to the original environment and start working back on that. So that is an additional feature that working with Git or working with any version control system provides you, that you have sandboxing feature out here. Okay. अच्छा, अब हम खास करके बात करेंगे गिट की. अभी तक हमने जो चीजें पढ़ा, तो that was all about version control in general. So there are other version control systems apart from Git. There is SVN, there is Mercury, there is Mercurial, there is Perforce, Bitkeeper, and many others. Many of them are not even used these days anymore. Subversion SVN is the one that is most commonly used after Git these days. So all version control systems aim to solve all of these problems that I just discussed. Okay. What does Git do differently? So Git is also another version control system. It does all of the problems that I just mentioned before. What does Git do differently? So let's discuss about Git. So Git is a distributed version control system. Okay, and the focus here is a lot is on the word distributed. So Git being distributed, not all version control systems are distributed necessarily, but Git is a distributed version control system. Okay. And a little bit of history about Git is that it was created in 2005 by Linus Torvalds for the development of Linux. If you guys know about Linux and the Linux kernel and Linus Torvalds, you would know that 2005 is not actually the time when Linux development started. Linus Torvalds has been developing Linux from a time much before 2005. So he originally used a version control system called Bitkeeper. Okay, so now Bitkeeper was scaling very well for Linux, but by the time in 2005, 2006, around that time, what started happening was a lot of people started using Linux and a lot of people started contributing to Linux, which resulted in a very high patch rate. That was that there are people contributing changes to the Linux kernel, almost more than one new change per minute. Okay, so that is a very you need a very highly scalable version control system to be able to handle this rate of churn in your code. Every minute somebody is sending some new changes to your code and that needs to be merged, and there are so many people, thousands of people contributing to it together. So at that point of time, Linus Torvalds figured out that Bitkeeper is not able to keep up with the demands of the Linux operating systems community which was developing Linux. So that's when he took a break of 2-3 weeks and he developed his own version control system and he called it Git. Git, basically the English word Git means a stupid person. So he said that Linux, the operating system, is named after me, and I would name Git, the version control system, after me. I am a stupid person, so I will name Git as it as Git. It's just a joke. So that is how Git started to be used, and the focus of Git was that merging changes, when two people have made two different changes in the source code and when you merge them, Git focused a lot on making that merge very fast. And when there are two files which have slightly different data, Git has a diffing algorithm which can basically tell you how many lines and how many variables and spaces and all how lines and words inside each line, how many of them are different, right? So Git made very good algorithms for diffing and merging, as a result of which Git became one of the highest performing version control systems, and that is the effect of that is that today in 2017 almost 80-90% of all open source projects all over the world, they use Git. Even companies like Microsoft, which has been developing their own version control systems for a long time, have now started using Git in many of their projects. अच्छा, तो हम अब बात करते हैं, थोड़ी सी टेक्निकलिटी की बात करते हैं कि गिट एक्चुअली काम कैसे करता है, ठीक है। तो वी विल मूव इनटू अ लाइव डेमो इन लाइक 10-20 minutes. First we'll just go through the basics, the most important technical terms that are involved in git. So सबसे important word git के अंदर होता है repository. Now repository is actually a folder. Okay, so repository is like a folder, or you can say it's like a project. So let's say you're working on this project, and you have a web server as a backend, you have a front end, and you have an Android app. So ideally, what should a Git repository be? Your backend should be a separate Git repository, your front end should be a separate Git repository, your Android app should be a separate Git repository. That's usually how we work with Git. Okay. Sometimes some people say put the backend and the front end together into a same folder and call the entire thing a Git repository. Basically, each Git repository is a unit. So जिस भी folder के अंदर के फाइल्स के चेंजेस को आप इंडिविजुअली ट्रैक करना चाहो विदाउट एनी रिलेशन टू एनी अदर फोल्डर, मेक दैट अ गिट रिपोजिटरी, ठीक है। तो गिट init कमांड होता है, हम अभी देखने वाले हैं, और उससे एक रिपोजिटरी गिट एनेबल्ड हो जाती है, ठीक है। So हम गिट लेके क्या क्या कर सकते हैं? We can collaborate with others, obviously, and when we collaborate with others, we get better solutions for the work that we are doing. We can make our work available to the entire world. But इन सबसे अलावा एक और चीज भी है. In every organization, every developer uses Git even for their personal projects, for the projects that they will probably never share out with the world, because इवन आपके एक सिंगल छोटी सी इंडिविजुअल प्रोजेक्ट में भी वर्जन कंट्रोल सिस्टम की जरूरत पड़ती है, इवन इफ यू डोंट वांट टू शेयर इट विद द वर्ल्ड। तो हम गिट यूज कैसे करते हैं? तो जो हमारी गिट की जर्नी है वो दो तरीके से शुरू हो सकता है। या तो ऐसा हो सकता है कि किसी की गिट रिपोजिटरी ऑलरेडी है और आप उस रिपोजिटरी को क्लोन करते हो, ठीक है। द कीवर्ड हियर बीइंग क्लोन, ओके, क्लोन। सो यू क्लोन द गिट रिपोजिटरी and then you start making changes to that repository. That is one way you can do. Or the other way is, if you are starting your own Git repository, in that case we use git init. This is for a new repository. Okay. तो अगर आपके पास कोई खाली एम्प्टी रिपोजिटरी और आप नया प्रोजेक्ट स्टार्ट करने वाले हो तो आप गिट init करते हो, और किसी की एग्जिस्टिंग प्रोजेक्ट को लेके आप आगे बढ़ना चाहते हो तो यू गिट क्लोन करते हो। कहां से क्लोन करते हो? दैट यूजर मस्ट हैव अपलोडेड हिज गिट रिपोजिटरी ऑन सम वेब सर्वर, एंड दैट इज वेयर गिटहब कम्स इन। गिटहब इज अ प्लेस वेयर यू कैन होस्ट योर गिट रिपोजिटरीज। वी आर गोइंग टू जस्ट डिस्कस दैट राइट अलोंग। तो अब हम ऐसा करते हैं कि थोड़ा बहुत हम एक गिट रिपोजिटरी को क्लोन भी करते हैं, और उसके बाद हम क्या कहते हैं गिट के कमांड्स क्या करते हैं वो थोड़ा सा साथ साथ में करके देखते हैं, ठीक है। सो व्हाट विल डू इज तो ऐसा है कि जो इस वेबिनार के रिलेटेड कोड्स हैं उन सबको भी मैं एक गिट रिपोजिटरी के थ्रू लोगों के पास अवेलेबल करा रहा हूँ, राइट। एंड आई एम मेंटेनिंग अ गिट रिपोजिटरी वेयर इफ आई रन गिट लॉग तो क्या आता है, यू कैन सी दिस काइंड ऑफ एन आउटपुट कम्स, और इस आउटपुट के अंदर बेसिकली क्या हो रहा है, यू कैन सी समथिंग कॉल्ड, यू कैन सी एक कमिट है यहाँ पे, ठीक है। ये चीज, देयर इज अ कमिट, देयर इज अनदर कमिट, ओके। सो फर्स्ट कमिट क्या है कि वेबिनार 1 का कोड हमने ऐड किया था, जो मैंने कल आप लोग पिछले वाले वेबिनार के बाद मैंने अवेलेबल कराया था, और उसके बाद मैंने गिट से कुछ फाइल्स इग्नोर हो जाए उसके लिए गिट इग्नोर ऐड किया था, तो ये सेकंड कमिट है। इस तरह से गिट लॉग करने से ये दिखाता है कि क्या क्या चेंजेस हुए हैं इस रिपोजिटरी में इन द पास्ट। सो गिट लॉग बेसिकली शोज यू दिस हिस्ट्री। अब हम ऐसा करते हैं कि एक दूसरी रिपोजिटरी देखते हैं जिसमें थोड़े ज़्यादा चेंजेस हो रखे हैं, ठीक है। So this repository is basically my class that my offline class where I'm also teaching Node.js. So here if I do git log तो थोड़ी सी लंबी लिस्ट आएगी, और ये लिस्ट थोड़ी नीचे स्क्रॉल भी हो सकती है, ऊपर नीचे स्क्रॉल हो सकता है। और उसमें आप देख रहे हो बहुत बड़े सारे कमिट्स है। एक सितंबर 24 को करीबी कमिट है, फिर सितंबर 17 को करीबी कमिट है, फिर एक सितंबर 10 को की कमिट है, एंड सो ऑन एंड सो ऑन, राइट। ये जो कमिट्स आप यहाँ पे देख रहे हो, यू कैन एक्चुअली ब्राउज दिस कमिट्स। These are all available on github.com/codingblocks archives, ठीक है। यहाँ पे for example which repository we are talking about is this webnode 2017 fall. So all courses that we do at Coding Blocks sources are all available. Okay, we are a very open company as far as that goes. So you can see यहाँ पे एक चीज़ दिख रही commits के नाम से 18 commits करके कुछ चीज़ दिखा रहा है, ठीक है। So if I go to 18 commits this, I click on this thing, तो see यही चीज़ दिखा रहे हैं event loops। 4 days ago I had made this change, LA 11 days ago I made this change, and so on. And if I click on any one of them, it is going to show me something like this. What all stuff did I add? That it shows up in green, okay. And if I remove any stuff, it shows that stuff in red. Let me see if I add. Usually I do not delete stuff in classes. We are just adding new and new things into the repository. So just to show how adding and removing and all of that works. So this, as you can see, gives us an idea of how this repository has changed over time. This gives you a history, and this is in reverse chronological order usually. सबसे top पे जो last change था वो दिखता है, और उसके नीचे उससे पुराने and so on, ठीक है। Okay. So this shows you basically the history. Then we talk about a commit, okay, and a commit is a very important thing in Git. So what is a commit? एक tiny सा example हम लेते हैं, ठीक है। बहुत ही छोटा सा example लेते हैं। हम मानते हैं कि एक फाइल है, ठीक है। Say we have this file, and some 2-3 lines were written here. This is on day 1, and then we go to day 2, and तब हम क्या करते हैं, इस फाइल के अंदर ये लाइनें लिखी हुई है, और हम कुछ न्यू कुछ और लिखते हैं यहाँ पे। Let's just use a good color coding here. जैसे न्यू लाइन्स को ग्रीन मान लेते हैं। So we write some new lines here, okay. That's day 2, okay. Then on this is day 1, this is day 2, then we go to day 3, and now we have these lines already written here, right. और क्या करते हैं हम, यहाँ पे कुछ लाइन्स हम ऐड रिमूव कर देते हैं, डिलीट कर दिया हमने। Like it happens when you're working with source code, right? You sometimes delete stuff, you sometimes write stuff. That's how it works. So basically What is the difference between these two entities is that you added plus these 4 lines, and that's how you went from this to here. Okay, and then how did you go from this to here? You subtracted some lines, and we went from here to this piece, right? uh, so what is a commit is that commit is actually exactly this thing, this entity is called so this is say commit number 1, and this is commit number 2. Okay, so these are what commits are. The changes that you make to your file when you go from one state to another state, that is called commit. And this example shows you one file, but actually Git can track changes across the entire folder in all of its subdirectories, sub-subdirectories, sub-sub-subdirectories, and so on. All files, all subdirectories, everything. It can notice changes anywhere in that directory. Okay, new files being added, files being deleted, files being renamed, content inside files being added, content inside files being removed, and all of that stuff. Okay, so that's how it was. Then we're going to talk about branches. Now, what are branches? Branches are a very interesting concept. Branches help you work on different features or different bug fixes parallelly without conflicting with each other. Now, let us consider the example that we were discussing. Say, if I make it like this, say I'm talking about this is the first state, and I go to second state, and I go to third state. Okay, and between each of this is some lines getting subtracted, and some lines getting added, right? So there has been some lines have been added, some have been subtracted, and this is basically the delta between this spot and this spot. Like that, there could be a lot of states in my code. It could so happen that my repository is like this. This is how it was on day 1, day 2, day 3, day 4, like that. Now, on this day, I decide that I will start working on a new feature, but this version of the software has already been released to the market, and people are already reporting bugs on that. Okay, they're saying something works, something does not work. Now, you cannot work on the bug fixes and the new features together because they are probably conflicting the same file. So what you do is you make the bug fixes on this particular point of code, make those changes, and go to a new node, and at the same point of time also add some new features into your code, and you get to a new state. Now, both of these states have originated from this one only, right? Now, what happens is you keep adding new features, and say this was version 1, and now you are on version 2, and you want to release version 2, but the changes that you did here, those bug fixes need to be present in version 2 as well, right? I mean, you already fixed those bugs. Now you cannot now this is basically called, say, version 1.1. okay, version 1.1 is version 1 plus the bug fixes. Now you can't release version 2 and say, hey, the bug fixes that we did on version 1.1, they are not available anymore, so those bugs are back again, deal with it. Now, that's not a good way to do it. So what you do is you take these changes and you merge them back into version 2, and you have a new state. And say, call it version 2.1, and you release version 2.1 to the public, okay, and everybody is happy. So that's how branches work. Branches let you work on two parallel things differently, not conflicting with each other, and later on you can merge them if you want to. If you don't, you might not. It might so happen that version 2 does not have the same bugs, so you just simply ignore this. You can just remove this part, and version 1.1 was released like that. These two branches have nothing to do with each other. It can happen like that as well, okay? That's what branches allow you to do. We generally create branches using this strategy. We do git branch. This shows us all the branches, and git branch name creates a new branch, okay, and git checkout name of branch checks out a branch that you have already created. We are going to try out all of these commands, so don't worry. This, like, I'm not going to just give you a theoretical understanding. We're going to actually make a git repository, try out all of these commands very soon. Okay, so some of you are saying that right, that's the some of you are saying that you have not been able to understand the concept of branches, and why do we create branches in the first place. So we are going to use a practical example, and we will see what branches help us in doing. Okay. Let me just cover up the basics first, and then we are going to look at branching in practice, and we'll be able to understand even better. Uh, like you said, branches and merging happen this way. It looks like this when you merge branches together. Uh, so we can add features and bug fix in one node, and that's perfectly valid. But sometimes it happens that there are two people that there are maybe say two teams. You have a team which has been divided into two small teams. One team is working on the new features, and one team is working on the bug fixes. And if they code together on the same file, they will have conflicts with each other. So you create two branches and you work on those two things independently without creating conflict among each other, and later merge those changes together. Okay. um, so merging does not happen magically. Sometimes what happens is, say, the bug fix and the feature, they had different changes in different parts of the file. So that would be okay, if say there were two changes. Let me give you an example again of, say, this file, and we had this file like this, and from here we went to two different states. Okay. In one of the states, we added some new lines up here, and in another state, we added some new lines at the bottom. Now this is easy to merge, because when you merge these two changes together, you get a new file where all the changes are available, right? This is how you merge two changes. But what if instead of that something else happened, right? What if we had some changes here as well? Now let me just make this a little more apparent by saying that we added some changes like this: curvy lines here and straight lines here. So when we add them together, how should it look? Should it look like this, or should it look like this? I mean, you don't know, right? I mean, which is going to be the correct one. So when this kind of a situation happens, that there are two changes and they are in the same place in the same file, so Git cannot automatically merge those things together for you. What Git is going to do is it will show you two files. It's basically going to open this file up, and it will say, it will basically demarcate those two things separately. It will say that uh, Grid is going to come up with a solution like this, and it will say whether there have been two changes. So whether you want to keep this part, or you want to keep this part, or you want to keep both parts. Now that's in your hand now, and you can choose which lines to keep. You can choose to keep all the four lines like this, or you can choose to keep the four lines like this, interleaved one after another. Whichever way you want to do it, now it becomes your choice at this point of time, right? How you want to manage the changes after this point. So this is how it looks like. This is say coming from one branch, this part of the code. This part of the code coming from one branch, and this part of the code coming from another branch, and Git says which one you want to keep. So this way Git allows you to decide how to merge when Git cannot merge things automatically for you. Okay, we will try this thing also out. Okay, so there are some other commands like git stash and so on, which we are going to just check out a little later. Let's now go to creating a new repository and running some git inside that. Okay, what I will do is I will go to I will create a new repository. I go to your course folder. So I have this folder called git intro, and I'm on this git intro folder. What I do is I do git init dot. Git init dot means that I am initializing git right now in this folder. Okay, git init dot and enter. So it says that initialized an empty git repository in this particular folder where I was in, right? And now the first thing that I'm gonna do is I'm gonna write git status, and git status says I'm on branch master, no commits yet, and nothing to commit because this is an empty folder, completely empty folder. Um, so what are the stuff I'm doing? Let me just keep writing that down. So I did git init. Is Then git init dot. This document I would make it available to you later on afterwards so that you have it handy to look at what was done during the webinar. Git status. This shows me no on branch master, no commits yet, nothing to commit. Let us create a file here and let us start using this repository. Okay. Um, this git intro folder, I'm just going to open this up in a text editor. Okay, I am so sorry. I got a little carried away. Um, how do you get Git? Didn't cover that in the first place. A lot of you guys are on Windows. Some of you are on Linux. Some of you are on Mac. So how do we get Git on each of these operating systems? So the Git website is gitscm.com. Okay. This is where you can install Git from. Latest version of Git, as you can see, 2.14.2. You can download Git for Windows from here, and you can also get a version of Git for Mac from here. Or those of you who use Homebrew or Mac ports on port, they can use install Git via that. People who are on Linux do not need to do anything because you already have Git installed on Linux mostly. Just in case if you don't, so it's the command that I think a lot of you guys are well versed with. Sudo apt-get install Git is going to install Git if you are on Ubuntu, and if you are Mac, you can do brew install. Okay, if you are using Homebrew, or you can install the Xcode command line tools that gets you Git as well. Okay, so these are the ways in which you can get Git on either of these platforms. So on Windows, Git comes with its own Git command line. So it's recommended that you use Git CMD. It has better support for Git related commands and Linux type of commands. Commands like ls, rm, and all of that works better. Okay, so So Git kind of commands work on this on Git CMD. Me personally, I have configured PowerShell a little bit to use Git very well. So I use PowerShell for that. But you don't need to necessarily use PowerShell. You can use Git CMD. Git CMD is one of the best ways to use Git on Windows. You can keep installing Git, and let me just show you how Git works here. I'll just show you the part where we will init a repository, make some changes, add them and commit them, and then you can have like 5-10 minutes to try try that stuff out on your own. So how many of you are trying this out along with me? If you could just let me know over the chat how many of you are trying this out along with me. It would be great. Okay, so in this git intro folder, let me add a file 01.txt. Okay, so this is file 01.txt, or let me just say it's some JS file. Okay, that will be good. You will see some JS code also on the screen along with that. So any kind of file it could be okay. And what does this file do? It's gonna do console.log hello world. Console.log hello world basically means it just if you run this file, it just says hello world. That's it. Okay, it says hello world. That's what a hello world file does. That's what I have done. File 01.js. Now, if I go to my terminal, okay, and I ask git status. Now I have a different kind of a status here. It says on branch master, no commits yet. Now it says untracked files, file 01.js. Why does it say so? Because now there is a file called file 01.js which Git does not track yet, but Git knows that a new file exists now. Okay, so what do we do with that? What do we do with this file? What I'm gonna do is I'm gonna add this file and commit this file so that this change gets recorded. Now how to do that? We need to do git add file 01.js. Okay, I'm just keep on writing that stuff so you keep remembering it. So I added a new file, then I did git status again, then I did git add file 01.js. After that I am going to do git status again. Okay, so here we go. What happens when I write git status again? Now it says that again on branch master, no commits yet, changes to be committed, new file 01.js. So there is a new file that is about to be committed but has not been committed yet, because if I go and git log, you see git log still says that there are no commits yet. So this change hasn't been registered yet. This change is going to be registered when I do git commit. Okay, I write git commit, and a new text editor is going to open up inside my shell. It says write some status message here. Okay, so give this commit a message. So this commit message is you describe what did you do in this commit. So let me describe that. Let me write added file 01 to project, and that's it. So this is the Vim text editor, Vim, and the most visited question on Stack Overflow is how to exit Vim. So let me cover that in this webinar. You write :WQ, write and quit. Okay, that's it. Your file has been committed, right? Now let's do git log. Git log says that there is this commit by author Arnav Gupta, Arnav at codingblogs.com on date Thursday, September 28, 1951, which is the time right now. And the name of the commit is added file 01.js to project. And if I do git status now, it's gonna say that on branch master, nothing to commit, working tree clean. Why is the working tree clean? Because whatever changes were there, I have registered it into Git, and Git does not find any new untracked changes anymore. Okay. Then let us add a new file. File 02.js. File 02.js. What does file 02 do? Console.log. Okay. We are learning Git. Okay. So now git status again, and it says on branch master there is an untracked file, file 02.js. Just keep on adding that stuff. Git status. Then what did I do? I did git commit wrote commit message and exit. Then I added a new file 02.js. Now I went ahead and wrote git status again. I will add this file also same way. Okay, git add file 02.js, git commit. Now if your commit message is just a single line, you don't need to open the editor at all. You can write git commit -m. Okay, this is -m here, -m, and then write your commit message right here. Add file 02.js. -m lets you write the commit message right in the same command, and you don't need to open the text editor to write the commit message. Here you go. And now if I do git log, there is the first commit here, and here's the first commit, and here is the second commit. Okay, so I'll just take a pause. I will pause for like 5 minutes. You guys can try this out, make a Git repository, and add some files, commit. Some of you might get a little error. It says author is not specified in the Git repository or something like that. User and author are not specified, and if you get such an error, then simply write this command, git config global user.name. Don't write my name, write your own name. Okay, and similarly git config global user.email. Again, write your own email, don't write my email. Okay, so writing these two commands, they help in doing what exactly is that every time I'm committing, it takes my author name like this, you can see, it takes it from the git global config. So you add that to the git global config, and then in that case, every one of your commit will contain your name and your email ID. Okay, you should configure git with your name and your email ID when you first set it up, right? One more thing, if you guys, are having problems using Vim, you can also add another git config to use Notepad for git commit message. Write this command git config global core.editor notepad.c. Okay, like that, and every time you have to make a git commit, you will open up Notepad instead of Vim. Okay. Yeah, git bash and git cmd are the same thing. You can use either of them. So you guys try the things out, and just waiting for like 3-4 minutes. If you run into any problems trying these things out, just let me know on the chat, and I will just continue with if you have been able to do what I have done till now, I'll just continue with the live stream. Okay. Okay, so guys, let's move ahead with what we're doing. And now the log looks like this. By the way, you can get a more concise version of your log using this command: git log double hyphen one line. That gives you a sorry one pardon my typo. You can get a very concise log like this. Okay. Good. Now, let us about this. Let's make some changes to file one. Uh, Function greet name console.log hello plus name, and then it calls greet with Arnav. Okay. uh, just think that it's gonna look like this. um it's does nothing really. I mean, you run this run this file. It does say hello greet hello Arnav, because I pass Arnav as an argument into greet and to console.log based on that. as far as Git is considered, if I do git status now, it's gonna tell me that file 1 is modified. Now you can see a little difference in the wording here. It does not say new file, it says a modified file. Okay. At this point of time, you can also check what modifications are there. You can do git diff, and it will tell you that what changes have happened in your file. Git diff, and like you can say, this line was removed and these lines were added. Okay, so and you get very nice color coded, red lines removed, green lines added. You get an idea of what has happened, what changes have happened to your function. We do git add file1.js. Now git status, it says that file 1 is modified. Okay. If you do git diff now, you're not going to get any differences. So git diff only shows differences between what is not staged for committing, right, and what has already been committed. So if you already added something, not yet committed, but you have already added something, so that does not show up on the git diff. Okay. Now how do I commit it again? Git commit m greet by name. Okay, so now if I do git log, one line, I'm just using one line now to use shorter git logs. See that added file 1, added file 2, and now greet by name, 3 comments right here. Okay. Now let us say we create a branch here. Okay, we're going to create a branch. So we do git, and this command is git checkout b hyphen b creates a new branch. Git checkout hyphen b, and name of the branch git learning. Okay, so I create a new branch called git learning, git checkout hyphen b git learning. And so now if I do git branch here, it shows that there are 2 branches, it's master and git learning. I am on git learning branch right now. Let's make some changes in this file 02 in the git learning branch. Console.log, hey, we are running git. Use git status to check status. Use git log to see history. So I added some extra lines into file02.js, and now if I do git status here, it shows that file 02 is modified. Git add file 02, git commit m more git information in file 02.js. Okay. Now to git log. Something interesting, you will see that the branch master has only come to this place, while the git learning branch has more git information in file 02.js. Now at this point of time, I would like to create a new branch out of master again. So I do git checkout master. Okay, if I do git checkout master, what happened to file 02? You see those lines just magically vanish from here. That's because on the master branch, these edits don't exist. Okay. Now, let's say I create another branch, git checkout b greeter. Greeter is a new branch, and in this branch, I'm gonna add some different changes. Okay, what I'm gonna do is I'm gonna make this greeter a little different. So I'm gonna do knock 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 name, knock 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 name, and knock 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 name thrice, like children does. Okay, and made some changes into file 01.js. So now git status, it shows modified file 1, git add file 1.js. By the way, you could also use wildcards. You can use git add start.js, that adds all js files. Git commit m children greeter. Okay, so commit here. So now if I go to git log, it shows that there is Sheldon greeter in the greeter branch, and there is this master branch. So now my situation looks a bit like this. I had some original source code like this, and at one point of time I deviated into a branch, and I call this as greeter, and I created another new branch, and this one I called git learning. So changes that were there here, okay, and the changes that are there here, they are different from each other. Now if you want to have a situation where you get the changes from here and changes from here all merged together, so what you can do is you will basically have to either merge greeter into git learning, or you will have to merge git learning into greeter. Okay, uh, how do we do that? That we do git. So right now I am on greeter branch, so I can merge git learning into the current branch. So merge always merges the argument branch into the current branch we are sitting on right now. Git merge git learning, and the merge has happened. Now if you look at git log, you'll see that there is this commit, which is add file 1, then add file 2, then greet by name. Till then this was common master branch. This was all of this part. Okay, it was all this part here. Okay, so this was all of this part. Okay, then there is the git learning branch, and there's the Sheldon greeter, and we have a merge branch commit. So we have the git learning branch, shade it a little differently. There you go. This is the git learning branch part, and then when we merge it, it creates a new commit here. This change is merged. Okay, and this commit here, is what you see. Right. Merge branch git learning into greeter. Now this view of looking at commits is a little linear in nature. We can have a very nice looking view of the git graph like this: git add, git log, and look at all the arguments that I'm putting here. One line, color, graph, decorate. Voila, you get a proper branch wise graphical system here, which shows you that the branches had diverged at this point of time into one branch here, and then they merged back here. Okay, this entire thing is very visible like this. So you can use git log, one line, color, graph, decorate. So let me just add all of the style stuff that we did here. How to create a new branch, get checkout be new branch, okay, and git checkout existing branch. This oh, create a new branch like this, checks out an existing branch using this command. And how do we get this nice looking graph? Get uh, git log, one line, color, graph, decorate. Fancy stuff. Now you're tired of writing this entire thing over and over again, you can create something called an alias. Okay, it allows creating aliases. Another very nice thing to learn about Git. You can add an alias like this: git config global alias dot, let's say, full tree. It shows you the full tree, right? Git config global alias dot full tree, uh, log, color, one line, graph, decorate all. Okay, we create this. We need to put this inside a string. There we go. So now if you write git full tree, it actually runs the command log color one line graph decorate all. So this way you can create aliases. We can create aliases for common commands that we use a lot. Okay. So now what we're going to see is how do we publish this Git repository onto the internet. So what we're going to do is I'm going to my GitHub repository and I will be adding a new repository here. So how to use GitHub? Basically, we go and create a new repository, and I call this repository say git underscore intro, just like the name of my folder. Although naming the repository and the folder same is not necessary. You can name it anything else. Trying out Git and teaching how to use it. So it's going to be a public repository. I click on create repository. Create repository. Now, so this repository is empty right now on GitHub. It does not have any stuff here. So how do I publish the repository that I have on my laptop to my GitHub repository? Now to do that, these are the commands that we have to use, already given here. GitHub already publishes that for you. So we need to do git remote add origin this. What does this command do? This adds a new remote repository. Remotes are basically copies of your repository to which you can push so that you can publish your Git repository for other people to see on the internet, or you could do it locally also. Your remote could be on the LAN, it could be inside the same company. Big companies, they use Git repositories to work in their own teams. It might not be out in the internet. You might be just pushing the data to some central server inside your own company. So we copy this command git remote add origin and the URL of your repository. In fact, you can actually exclude this .git part also. So basically this is simply this URL, exactly this URL that is there on your URL bar. Okay, whatever this is, github.com /git intro git remote add origin. So it adds a new remote like this, and then I'm gonna push git push master. What does this mean is that I'm going to push my code to origin, and origin is this thing which I've already defined. This is origin which I've already defined. And what branch am I pushing? Master branch. Is that whenever you start working on a repository, the first branch that gets created is the master branch. Okay, so I'm going to push the master branch here. So what does that achieve is that let us refresh this page. Right. So why does that bring us is that this repository, you see master branch is there and there are only 3 commits. The first 3 that I did, add file 01, add file 02, greet by name. That's because I only push the master branch here right now, not the other branches. Now, if you have more than one branches and you want to, push all of them together, you can do is git push origin double hyphen all, and when you do double hyphen all, you will see that all of your branches get pushed into origin. Git learning and greeter have been pushed as well. So there we go. Refresh this page, and yep, Git learning and greeter are available here as well. Now there is a very nice thing on GitHub which shows graphs, and inside graphs you can look at network, and it shows you how this repository looks like. From master we created git learning, which was merged into greeter. Okay, so this kind of a thing is shown to you in the network repository. Okay, let us do something. So if somebody's code exists on the internet, if some repository already exists, how do we so this time we just created a new repository, we did git init, and we made changes to this. Now the next thing we want to learn is how to use GitHub to take an existing repository, make some changes to it, and then contributing it back to the original repository owners. How do we do that? So what I'm going to do is I'm going to go to coding blocks, and we have this repository called make a PR. Now this repository is an example repository that you guys can use to try out how to make pull requests to GitHub. Okay, to do that, obviously we would need to fork this repository and then make a pull request to this repository. Now these words might sound very overwhelming. Fork a repository, pull request a repository. How does that happen? I'll just walk you through it. Okay, so now I am a member on the coding blocks organization, so that's why I can make changes to this repository. But if I was not a member of coding blocks organization, then that would mean that I cannot make changes to coding blocks / make a PR. Okay, but if say there is this repository, coding blocks / abc, and I cannot make any changes to this. But what if I create a clone into my username as inside my GitHub account as champion swimmer, which is my username / abc. Now here I can make pushes. I can push and it is gonna work. If I push into this is not gonna work because I do not own this repository. But this repository I own, and it's a copy of this repository, and I can push data into this repository. Okay, so let's see how to fork, clone, make changes, and then ask the original repository maintainer to take your changes into their project. Okay, so what I'm going to do is I'm going to go to this repository and I'm going to go to this fork button here. Okay, fork. It's visible to you, I hope. Just if it's not, fork button is this one. Okay, So that's how you create a fork. So click on fork. Oh, I have a fork of this. So that it does not make conflict. Let me just do is I'll just delete this repository. Okay, just delete this and fork it all over again to show you guys how it works. Okay, some people might get a public key error when you're pushing to GitHub. Just make sure that your remote git remote hyphen v is going to show you the remotes. Okay, so git remote hyphen v, and make sure it is the HTTPS version and not the SSH version. Okay, if you go to GitHub and look at any repository, the one that I made, for example, you'll see that there are two URLs. There is the HTTPS URL and there is the SSH URL, which looks like this: git@github.com, champion swimmer git intro. Okay, so using the SSH one requires you to create SSH keys. It could be a little difficult for you because you're just beginning to learn Git. I would suggest you make sure that you use this one. You use this HTTPS one, okay, not the Git one, okay, not the SSH one. Okay, yeah. Coming back to what we were doing. Let me just so I deleted this repository. Now I'm going to create a fork. And if you guys are new to GitHub, you won't see this long list of repositories. I am seeing this list of repositories because these are all organizations that I own or manage. So I can fork to any one of these, but I'm going to fork it to my own personal account here. And this creates a new repository, champion swimmer / make a PR. Okay. So notice what I'm doing here. What I'm doing here is I have this repository. Coding blocks / make a PR. What did I do? I did an operation called fork. What does that give us is the same repository under my own account, champion swimmer / make a PR. Now what I'm going to do is I am going to clone this repository. Okay, let's understand this thing. This part of the world, this rainbowy part, colorful part, is the cloud. Okay, so when I forked, the repository was still on GitHub. Okay, it did not come to my computer. When I clone, it comes to my computer. So this part of the world is my laptop. So I'm going to clone it and bring it into my laptop. Okay, how am I going to do that? Is that I will go here, simply copy this URL. Okay, the entire URL of my website, I'm going to copy it. I'm copying it from championsimmer.makeupr, not from coding blocks. Okay. Then I'm gonna go to my folder here where I was, and I will do git clone and uh, copy it. There we go. So git clone and simply just copy paste the URL from your web browser. Okay, that works. And what do we get? It says cloning into make a PR, and there we go. It has been cloned. In my Visual Studio Code, let me just new folder. I'll open a new folder. I'm gonna open this make a PR one, the one I just cloned. Okay, right. So what do we have here? Hmm. Now, what does this repository tell us? This repository is what is this about? This is a repository that I have created for helping students, learn how to make a PR. What do you need to do for this repository? We have done this step. Clone this to your PC. Done this. Add your profile page. Then commit and push. Then create a PR, and we have to start this repository. Okay. So there have been some people like Ankush here who has pushed his file to the wrong place. He has pushed it into the root folder while he had to push it into the students folder. So let me just correct that for him. Let me drag this and move it into students. There we go. So I moved Ankush to students. Okay. And this example file is a waste. It's an example, it says test, it says nothing. So let me just delete this file. Cool. Now let me see what does git status say now. Git status says that ankush.md was deleted, example was deleted, student slash ankush.md was added. Okay. So let me do git add. And if I want to add all files in my directory, I can use git add hyphen capital A. Git add hyphen capital A adds all files in this current directory. There we go. Okay. Git status. Now ऐसा है कि जब तक ये ऐड नहीं होता फाइल, तब तक क्या होता है कि वो इस फाइल को डिलीट होते हुए और इस फाइल को ऐड होते हुए अलग अलग दिखाता है, बिकॉज गिट हैज नॉट एक्चुअली लुक्ड इनटू देयर कंटेंट्स. But when we add this, now Git realizes that एग्जाम्पल तो डिलीट हुआ, बट ankush.md सिंपली रीनेम होकर student/ankush.md हुआ है. ठीक है. एंड लिनक्स टर्मिनोलॉजी में मूव और रीनेम एक ही चीज होती है, सो दैट्स व्हाई इट्स कॉल्ड जस्ट रीनेम्ड ओनली. एंड देन git commit, and let me just add some message, clean up the repository. Okay. तो मैंने ये क्लीन अप किया. अब मैं अगर रिमोट देखूं तो मेरे पास ओरिजिन रिमोट बना हुआ है, क्योंकि मैंने वो क्लोन जो किया था. whenever you clone something, so what happens is you get a repository like this here on your laptop. You get make a PR. Um, Here, there would be something called origin, a remote called origin that actually points back to the place from where you had cloned. Okay, inside your local laptop, there would be something called origin that points to the place where you had cloned from. You don't need to add this remote like we had done before, git remote add origin. That we do not need to do, because when you clone from some place, it automatically is added as a remote. What do you want to do? Git push origin master, same stuff. And this commit that I did, clean up the repository, would get pushed. Now if you look at the repository, this is my repository. And you can see the latest commit is me doing clean up the repository. There are 110 commits and the latest one is me doing clean up the repository. Okay. And in the coding blocks repository, there are 109 commits, one less. And the last one is this Shivanshu Chaudhary adding his file. And here I have added one commit additional to this. Okay. So now this repository here, if this repository can be denoted like this, my repository is very similar, only it has an extra node. Now this is the last commit that I added. Okay, so now I want coding blocks to pick this up into their repository, okay, and add whatever I did into their source code as well. So to do that, what I need to do is create a pull request. What a pull request is, I'm gonna ask coding blocks to pull my code, because I cannot push to coding blocks. So I will ask coding blocks to pull my code. That is what a pull request means. So we go here to my repository, you go to the front page of the repository, and you will see this button here called pull request. It will show you two things. It's going to show you that you are one commit ahead of coding blocks master, and you will get this button here called pull request. So this is the one that we want to click. Okay, so we're going to click this pull request button. And a new pull request is created. Okay, two files have been changed. Ankush.md has been moved to students ankush.md, and example file has been deleted, test has been removed. I am basically sending this head fork to the base fork. I create a pull request, create pull request, and there we go. A pull request has been created. Okay, this is how you create a pull request. Now I'm just changing my perspective. Now I'm looking at this from the perspective of being an administrator at coding blocks. Now, because I am at coding blocks, I can look at the pull request and I can figure out if this pull request is a good one or not, if I want to merge this or not. So I can look at the commits in this pull request. Now, one pull request may have more than one commit. Okay, it has this clean up this repository commit inside that. The files that are changed, I can look at them, and if everything looks good to me, I can go and merge this commit. When I click on merge, that is the equivalent of doing this work, adding this into the coding blocks repository. So one repository being merged into another is very similar to how a branch gets merged into another. It's the exactly same process. Now in coding blocks.make a PR, I can see that the ankush.md file has been removed, and example file has been removed as well. So this pull request worked. So what you guys can do is do the same thing here. Come up and fork this repository, add your profile page to the students folder, and then push it to your repository first, and from your repository create a pull request. So I'll get a pull request, and I will merge your pull request, and then your name would be present in this repository. So I would love to see if somebody is able to do that during the webinar itself right now. Okay, it would be really nice to see that. Here when you're creating a profile page, you can create it using this language called markdown. So markdown language looks like this. Okay, if you write single hash, okay, that creates heading 1 like this. If you write double hash heading 2, similarly up to 6 hashes heading 6, then you can create links like this. You write square bracket, you write the text, inside curly, round brackets you write the link, so it creates a link like this. Okay, and you can create images like this. You can embed images. You can write italic text using the underscore highlight, and using star highlight you can write bold text, so like this. Okay, so it's a format that is used largely by almost all GitHub organizations, all open source projects, to document their code, to write readme files. Markdown, it's a markup language, but it is not as complicated as HTML is. It helps you do very basic markup. Okay, simple heading, bold, and all of that stuff. So let's see if any one of you right now watching this webinar can come up and make a pull request to this repository. Anyone is going to try? So I'll just give a tiny little break of 2-3 minutes, and then we are going to discuss two very important concepts, two theories in Git. How are commits made? How are commit hashes made? How does Git maintain the integrity of a project? A, and B, we're going to learn about how the add, commit, stage, all of that process works. What does that mean? What does that actually mean when you're adding a file, then committing that file, pushing that file, how all of that stuff works. Okay, so we're going to look at that really soon. I'm just going to give you a 2-3 minutes break. Anything that you're stuck with, please mention that on the live chat. And if somebody is trying to make a pull request, please do. I would love to merge your pull request right now. Okay. So let's discuss about two things. First, how does staging and editing all works? Okay. So oh, we got some pull requests. So we have got one by Hashroot. We have got one by Harshit. So that's really nice. Uh, Harshit has done the same thing that I have done. So okay, merging Harshit's pull request is not going to make any change. Hashroot has added his profile page. You need to add a space here. Okay. Mm, so basically need to add a space here to make it headline one. Okay. Right, there we go. And let me just merge your commit in. Okay. So so whoever is Harshit Hashroot, thank you so much for sending in the pull request. Guess you guys have gotten an idea of how it works. Definitely send across your pull requests today, tomorrow. I will merge them if you're adding things here. It's really nice. It gives you an idea how to make pull requests. That's how you start contributing to open source. Some of you said you were interested in participating in Google Summer of Code. The first step to participate in Google Summer of Code is to understand how pull requests work on GitHub, because most of the projects are going to be on GitHub, and you will have to clone those repositories, and then you will have to make your changes and send pull requests, and then the organization will merge your pull request, and that's how your open source journey is going to start. Okay, we are going to come back and discuss about two things. Like I said, one of them is about how does the staging process work. Okay, so let's talk about that. Okay, so let me just make a line here. So you are going to have three areas in your file, okay, in your repository. So there is a sorry, yeah. So there you go. So there is a place where there is your history out there, okay. Mm, and let's say we just add commits to this one by one. And so on. Now, what is this thing called is your Git history basically. Okay, so this is called your Git history. Mm, this is called your Git history. Okay, then you have got something called the staging area. Okay, we have a staging area. What is the job of the staging area? We're gonna discuss that soon. This is called the staging area. Okay, and now you have got your folder. Now, ideally, what's going to happen is at any point of time, the state here is going to be equal to the last commit. Okay, because whatever the last commit has happened, the your state is exactly going to be the same as that ideally. Uh, so now you make some changes to a file. Let's say some file exists. You let's say, let's take an example first, is that you add a new file. You add a new file. It has some lines of code written inside it. Okay, so now this file can go into the staging area when you call git add. Okay, uh, and if there was some file that already existed, if there is some file that already existed here, right, there were all these lines added, and then you just add some lines into this file. Now this file automatically this file automatically moves there. Oh, sorry. Now this file also goes there when you do git add. Yep. Now everything that is in your staging area is, so now you have got this file, and you get the only the changes of this file, because the existing data does not come into the staging area, only this part, right? And all of this stuff gets bunched up together and goes on to become commit number 4 when you run git commit. Okay, so that's how it works. You have a folder, you add a new file, or you make some changes to a file. They are by default, git does not put them in the staging area yet. Okay, now the importance of this staging area is very huge. You could have made a lot of changes and you can commit only a part of it. Let's take a look at how that happens. Okay, uh, let's go to this other project that we had, git intro, right? And we are on the greater branch, say. Okay, So what we do is we add something like here console.log. Nice to have you here. Okay, git status shows that sorry, let me just save this file, and then git status shows me that file 01 is modified. I do git add file 01.js. Then I'll add a new line here, console.log, would you like some tea? And I save this file. Now if I do git status here, you're going to see that file 01 is present inside changes to be committed heading as well, and it is also present inside changes not staged for commit. Now same file cannot be staged and not staged at the same time. What actually has happened is that this line of code here has been staged, and this line of code here has not been staged. I can prove that. Git commit sm okay, and if you do git status again, you see that file 01 is still showing an it is still saying changes not staged for commit. And let me just push it, git push origin greeter, right? Let me just look at the source code now. On the greeter branch on file 01.js, you see only this line has been added. Okay, so what we can do is we can take a file like this, add 2-3 lines of code, then call git add, which would register these changes. Say it already had some lines out here, these changes get registered. And then if I later on add some more stuff and have not yet called git add, so these lines are not present here. Okay, these lines are not present here. So when I'm going to commit it, when this is going to go as a commit, so which part is going to go? Only this part is going to go, and these lines, the pink one lines, these are not going to go because they never came into the staging area in the first place. They were right here, they never came here. Okay, so you can partially stage files and then commit only the staged part of your stuff into the git history. Okay, so this is an important thing to understand of how git add and then git commit works. Okay, if you understand that, you'll be very good with using git. Okay, is a lot of people use git like it is Dropbox. So git is not to be used just like Dropbox. Git is to be used with all of these staging and filtering and all of the support that git provides you. Next, we're going to talk about how does git provide integrity to code. If you get the source code of a program and you know the commit id, then it is very hard for somebody to tamper with that code and change the history of git. Now what we're going to discuss is there we go. If you look at git log, you will see that this Hmm. This commit ID. Okay, this is called commit ID. What is it exactly? It is basically a SHA1 hash. So SHA1, please do read up on that. It's a cryptographic technique to create hashes. What is SHA1? Definitely read up on that. Recently, Google cracked SHA1. They collided two different files with same SHA1. It's a nice topic to read up about. Okay. So what does this commit ID signify, and what is the importance of this commit ID? So let's understand this in this way. What happens when we are committing things on Git is that, say, you start with a Git repository, okay, and so this is the base of my Git repository. So I'm using a earthing symbol to show that this is an empty folder, no stuff here, okay. Uh, we want to go up and let's call this as state 0, or let's call this as state 1. So what is state 1? State 1 is some files and some code inside it. Then we go to here and we call this as state 2. Then we go here, call this as state 3. Okay. So SN, what is it? It's the state. What is the state? That is basically files and lines of code in them. Okay. And we go forward as 4. Now, if we talk about the commit that took us from S0 to S1, this commit. What is this commit is going to be? Let's call this commit as C1 is equal to delta S01 is equal to S1 minus S0, right? So what are CNs? CNs are commits. What are commits? Commits are lines added or removed. So commits are basically deltas between states. So then there is going to be, this is going to be C1, this is going to be C2, this is going to be C3, and so on. Okay. Now what happens is we can use now this point is denoted by this commit ID. This point is denoted by the commit ID. Okay. Now in Git, what happens is, say there is one repository which had been like this. Okay. So say you are right now standing at this point. Okay. Now if you want to see how the code looked like at this point, what you want to do is you want to go and stand here. To be able to do that, the command that we use is let's say the commit ID here is X. So we do git checkout X. Okay. Now if at this point of time you want to add the changes here, this changes that happened here, you want to take and add it on top of this. Okay. So whatever changes happen between these 2 point of time, you want to add this here. So a good example, like I said, was that if this is a v2 branch, this is the v1 branch, bug fixes in v1 we want to port into v2, and we only want this part. We don't want anything from here, we don't want anything from here, we only want this part to be coming into our v2 branch. Okay, so to do that we use this command git cherry pick x. Now you will notice something, that in this case x refers to a sn variable, and in this case x refers to a cn variable. Why? Because when we are cherry picking, we are only taking the delta, and the delta is basically a commit. But when we are checking out, we are considering the state. Okay, and you can also do git log x. Git log x will basically show you this entire history. This entire history would be shown to you using the git log command. Now when we are doing git log x, in that case x is being treated like a entire tree. Okay, so how can this same variable x refer to a state, a commit, and also the entire history? How can the same variable refer to all of these three things together? Now to understand that, let us understand how hashing algorithms work. So how do hashing algorithms work? There is a hash function. You take x, put into hash function, it gives you y. You take x dash, you put into this, you get y dash. Okay, and so basically y equal to hash of x. These are hashing functions. Hashing functions have a property, this y dash, and all kinds of outputs from here. They all are of the same size. They are equally random. So if you take x and you make a very small change, let's say do +1, and you get x dash. So that does not mean, this does not mean that y dash minus y would be 1 or any function of 1. Okay, so that means that whatever changes you do to x, so if you take, say, x equal to a b c d e, and you take x1 equal to a b c d e f, and we make hashes out of these, so y would be something like, say, 2 7 b a d, and in this case y dash would be, say, 3 e 4 h j. I mean, there is just going to be no relation between these two. There's going to be no relation between these two, although here we can see a relation. We have just added a f. Okay, so we just added f here. There's no relation between the changes in y. So whatever the hash function generates is always going to be purely random. It's and every time you hash the same x, you get the same y. The size of y is going to remain constant. You can read up a lot about hash functions on the internet, what hash functions do. Now the property of the hash function that we are relying on here is that if we take a very large piece of data, okay, and we just make one little change here, okay, the hash function will change drastically. Okay, these two will have no relation at all. The hash function will change drastically even if you make a very little change inside your x. Okay, so taking these concepts into mind, how do we create commit IDs? Okay, so how do we create commit IDs? It's a very interesting concept in how Git works. So let's say we have this as the base state. So commit ID C1 is equal to hash of, or we'll just use the hash symbol to be nice. It's a hash of delta S 01. Now, if it is so, that would mean that basically Cn would be hash of delta S n minus 1 comma n, which means that whatever changes happen between these two places, we take this as a hash, and that gives us the commit ID. So if somebody tampers with this change somewhere here, that means that this also will get changed to a new hash, right? So if somebody changes the commit, somebody changes the lines that were added or the lines that were deleted, if somebody makes any changes, the commit ID changes. But the people who developed Git, they went one step ahead, and they said that instead of only this, what we are going to do is plus C of n minus 1. Okay, now that means that we again consider this case. There are some changes between these 2 points. We hash it and we get a commit ID. Okay, but what if somebody makes changes into this spot? Somebody makes some changes here. That means that this C will change, which would imply that whenever this gets changed, Cn minus 1, then also Cn gets changed. So if you change C somehow, this will also get changed. Okay. And to make it even more secure, what they said was plus you take some metadata. And what is metadata? M consists of the author of the code, the time at which it was committed, some info about your PC, which machine it was committed on. So now, if you consider this entire situation, if somebody makes changes in the code here, that would impact the value of C1, which would impact the value of C2, which would impact the value of C3, and so on. Now, if somebody did not make any change in the code here, but instead somebody made some changes in the metadata here, that would still affect C1, and that would still result in this entire thing happening all over again. Similarly, if somebody just simply takes this code and whatever changes happened here, somebody wants to just swap these around, take this there and this here. So, if I take a file and there are these 2 lines added here, and I go to this state, then I go to this state, Or if I do it the other way around, so I add first I add this here and then I add this. In this case, first I add this here and then I add this. Git can differentiate between these two cases. Whether you did this first or you did this first, Git can differentiate between the two things, even though the end result looks exactly equal to each other. So this is a very beautiful thing that Git does, and this is called Merkleization. You can check up on the internet what does this mean. This kind of a thing is called Merkle tree, and this process is called Merkleization. Merkleization is also the process by which you download BitTorrents. So you just need a single hash, and with that single hash you can verify if your entire file was correct or not. So Merkleization for BitTorrents happen in a little different way. You take your file, you divide it into chunks, you take hash from here and you take hash from here. And then you take the hashes of these, then you take the hashes of these. Okay, so any data you change, this hash gets changed, this hash gets changed, this gets changed, this will get changed. Okay, so you cannot tamper with any place inside this entire data without making without keeping by you cannot basically make changes to any place here and let this hash remain the same. Okay, so the same stuff with Git. You cannot change the commit, the contents of the commit. You cannot change the order of the commits. You cannot change the author, the timestamp, and the computer related information of the commit without triggering a change in the entire change, and all of the commit IDs will change. So it cannot happen that somebody releases a software, gives you the source code, and later on they make some changes in the history, way back in the history, and then they tell you that this kind of stuff was not there in our code ever. This bug could not have happened because of us. This kind of a thing cannot be done, because simply by looking at the last C here, you can verify the entire chain right till the back. Okay. So people have been asking that whether it's like blockchain hashing, and it's yes, it's very similar to how blockchain hashing works. Bitcoin, in Git, there is no concept of the block generating any money. But apart from that, the concept is very similar to how Bitcoin works. The cryptography protocols are a little less secure. We are using SHA-1 hashes, which have already been collided by Google. But in case of Git, it does not matter, because in a Git repository, making two different code changes on the same source code file and having the SHA-1 hash the same of both is not really easily possible. So just having x1 and basically having x1 and x2, both of whose hashes are y1, is possible. It's possible in SHA-1, but then x1 and x2 need to be meaningfully similar to each other to actually make this a damaging problem. Okay, so as far as GitHub is considered, this is not considered a very big damaging problem. As far as blockchain is considered, these kind of problems can lead to a lot of money being lost and people losing trust in the blockchain. So blockchain uses higher order cryptography functions, and they use a nonce, and they have certain standards for what kind of hashes are allowed, what kind of hashes are not allowed. So it's a little more difficult to create fake blocks inside blockchain. The security is a little bit more, but at the overview level, yes, the Bitcoin blockchain is very similar to how the GitHub chain basically works. It's the same Merkleization strategy that works here. Okay. So I guess that's all about Git and GitHub from my side. There is like what I have described about Git here is like probably 10% of what you can do with Git. There's a lot to explore, a lot to learn. So going forward, whenever you're starting to build a new project, this is the first thing you do is do Git init, make that folder Git enabled, and you maintain your entire project using Git. You will see that it will be easy to undo when you have some problems in your code. You will automatically start using the branch feature, and you will be working on experimental features in a safe zone. You would be able to collaborate with other people very easily when, like, tomorrow you want to share that project with some of your friends. That would be very easy to do later on. So use Git a lot. Okay. And I can already see like there are around 1, 2, 3, 4, 5. Oh, there are about 6 people who have already sent pull requests on the Makeup PR repository, which is really really good start. Okay, so do all of that stuff. I did promise to tell you guys a little bit about how GSOC and Google Summer of Code works. So very few people are still online, but still, if you are interested in knowing how that works, some of you would be watching this video later on after the recorded one, even after the live stream has ended. So how does Google Summer of Code really work is there are a lot of so there are a lot of open source organizations that work on a lot of projects which are open source. There is, like, for example, common software that there is VLC, Mozilla Firefox, and so many of the open source software that you use. Even, for example, the Chrome browser that you're using, Android, all of these stuff are open source. So many of these organizations, Google is a for-profit organization, so Google does not have problem funding the development of Android or funding the development of Chrome. But there are a lot of companies like Mozilla and all, which are not very strictly for-profit in nature. So, or at the Apache Foundation, which is one of the largest open source driving forces in the world, they recently made Facebook relicense the React.js framework in a open source license. Facebook had a very infringing license, which basically meant that you could not sue Facebook if you use React. Apache Software Foundation is such a big open source organization, they forced Facebook into relicensing React. So there are very big open source organizations, but most of them are run by people in their free time in a democratic manner. So Google, like a lot of other companies which help these open source organizations, you might think that why they help, because a lot of these companies are built on top of open source technologies. Companies like Google and Facebook would not exist if the LAMP stack did not exist. The Linux, Apache, MySQL, PHP stack did not exist. The Facebook original version was built on the LAMP stack, and it's entirely open source. The Apache is known for building the Apache web server, but other than that, Apache builds a lot of other things as well. MySQL is also open source. PHP is an open source language, okay, and Linux is an open source operating system. And a lot of good websites are built on this thing. WordPress is built on the LAMP stack. So Google, every year what they do is they invite a lot of these open source organizations, and they tell them that, do you have any projects that students can work on them over the summer? So they come and put up some proposals. So I will just show you some stuff. Let's take a look at what kind of proposals we have. So summerofcode.withgoogle.com is the website, the GSOC website. And there are a lot of projects you can find out here. So every year Google basically ask these organizations to come and tell that whether they have projects or not. They submit their projects, and then Google asks some students to submit some proposal and tell that, you write down or take a document, write down that this are the stuff that I will work on this summer for this particular organization. So for example, I worked with FOSS Asia. FOSS Asia had this project where they wanted to create an event management system. I created a proposal where I said that, I would love to build this event management system. I created some mock-ups, I made some wireframes, some diagrams, and I said that this is how I will make the event management system. So then Google asks FOSS Asia that, which student do you like? Which student would you like to have work for you this summer and build your project? So FOSS Asia said that, okay, we would love Arnav to come and build this project for us. And that's how I got selected. Then the entire summer I worked on that project, build that event management system. I worked for 2 years on the same project under GSOC at FOSS Asia, and then just this year itself, I have been mentoring that same project. It's now a very big project. You can create a event management portal. You can have a ticketing system. You can have a badge generator. It prints badges. Badges have QR codes. You can scan QR code to share contacts with each other at an event, at a conference. You can submit talks to a conference, and people can upvote and downvote. So it's a big system now. It started off with a very small Android app and a small website and like that. So how to go about Google Summer of Code is that, even before you come to this page, the first thing, and really the first thing, is that you can't work around this problem. Is that you need to learn some product-based technologies. Simply learning C++ or Java or just understanding data structures and algorithms will not work. You need to either learn how web development works. There are a lot of platforms for that. There is Node.js. This current course, the webinar is a part of this course. So you could learn Node.js, you could learn Django, you could learn Ruby on Rails, or you could learn J2EE, which is creating web servers with Java, or you could learn some front-end stuff like there's AngularJS, React.js, Vue.js, Ember.js. These are all front-end frameworks. There's jQuery. Or you could learn mobile development like Android development or iOS development. These days, there are a lot of projects which are in the field of machine learning and data science. You can pick up Python, Julia, or R language and take up a lot of data sets are available over the internet. Go to data.gov.in. There is a lot of data that the government publishes, and create some visualizations out of that data. Okay. So you need to pick up any one of these skills. And after that, you need to build at least, I would say, 4 to 5 good projects yourself. That's not just because to get selected you need to build your profile. That's simply to be able to understand the projects that are part of Google Summer of Code. You just can't say that, I have done an Android course and I will be able to understand the Android projects that Google Summer of Code has. It's not going to work like that, because these projects are being built by 10-15 people working around the clock from different parts of the globe. And there are some very highly experienced developers working on it. So these projects are going to be complex. They will have unit testing set up. They will have code coverage set up. They will have a proper architecture. Like as far as say Android goes, they would be using say MVP or MVVM architecture. If it's a web project, it could be using MySQL or Postgres, or it could be using MongoDB. So you need to understand a lot of technologies, and that is only going to happen if you come up with some of your own ideas. Think of what can you build. Can you make maybe a small game, a calculator, a carpooling app, or whatever, you come up with small ideas, implement that, make some projects of your own. You make 4 or 5 projects of your own, you get a better understanding of how to create a project, which files go where, how to look up a project and understand the architecture. You'll be able to do that more if you have designed the architecture of your own apps first. So do that first, make some of your projects of your own. You skip that part, you just say what, like a lot of people have been saying this on the chat, that you are not even able to understand, looking at a project, you're not able to understand what this project is about. It's Python. There are a lot of Python related .py files. It's JavaScript. There are a lot of .js files. You know Python, you know JS, but the project just does not make sense. You don't understand which file runs, which file calls, which file. You're not able to understand anything. That's because you have not worked on a project yourself. You have simply learned the language, and just learning the language would not be able to, that's knowledge that you cannot translate to working on projects. Make some projects, make some friends with people who have complementary skills. If you know web development, make friends with an Android guy or Android girl at your college. Make some projects, go to some hackathons, build some projects with your friends, make a team of 2-3 people, create some open source projects, put them up on your GitHub. Okay. Once you've done that, then you come to this page and you can search stuff like you can search by Android, and you get a list of Android projects. Uh, right. So these are all Android projects. You can look at these projects, what these projects were about. A lot of these projects, would be, continuing this year. A lot of times, because open source projects, these are big projects, they don't end in 1 year. So look at the projects that people had built last year. Talk to the students who participated in it. Talk to the mentors. You get the link names of the mentors here. You can simply Google search these people out. You will get their LinkedIn or Google Plus profile. So just ping them. There's a 50% chance you don't get a reply. That's fine. Some people ignore some of the channels. There's a 50% chance you get a reply. Don't bug them with very silly doubts, but ask them, what's the roadmap of the project, what ideas they are planning to build into their project. And the submission period of Google Summer of Code proposal submission happens in February, but you need to start gelling with the organizations that you want to contribute to. You need to start talking to your organization right from November, December, January time. Start making pull requests to them. We have seen how to create a pull request. Clone their repository, build that app, see if you can fix a bug, you fix it, push it to your repository, make a pull request, wait, what happens, look what happens. Okay, so that's the way to go about it. Some of you would be attempting Google Summer of Code 2018, so all the best for the people who are going to do that. You can obviously at any point of time want to ask me further about how to make a good proposal. There are like almost all the mentors at Coding Blocks. I think 70-80% of them have either participated in GSOC before or have been mentors at GSOC. So at CB we have a very good team of people who have been part of open source communities. Our own projects, a lot of them are open source in nature. So you can just reach out to me at a@cb.lk if you want to get a proposal reviewed, want to ask anything else, want to ask which projects you want to target or anything else. So just feel free to do that. So all the best for Google Summer of Code 2018. I guess at Coding Blocks, those of you who are in Delhi, to try to organize a meetup sometime in the next couple of months around GSOC. So I think what we plan to do is we will have a open source meetup where people would be discussing their open source projects, and we will have an app demo also. So people who have built apps, students who have built apps of their own, they can come and demonstrate their projects. So that would be really nice. Let's see, the next couple of months we are planning to build all of that. So thank you so much for attending. The people who are part of the course, some of you have not added to Slack yet. I will add you guys. I did not have the entire list of all email IDs, right? So I just got the entire list of all email IDs. I will add it to Slack. If you have any doubts about this webinar or the last webinar, please feel free to ask me on Slack or on the WhatsApp group. Okay. And people who are not part of the course, just publish a comment under this YouTube video and we will reply. Okay. So thank you so much for watching and good night, everybody.